Seeing Spaceship Earth brought a great paradigm shift in science. It changed our scientific understanding of the planet. And it led to our scientists becoming our planetary navigators, warning the rest of us that we are flying into danger.
Keiner aussteigen kann. Und ich denke, dieses Bild, der blaue Planet oder Raumschiff Erde, das ist durch die bemannte Raumfahrt tatsächlich geprägt worden und hat Wirkung erzielt und bewirkt weiter. Das hat die Wissenschaftler durchaus motiviert, sich mit dieser Thematik intensiver zu beschäftigen, alle mit dem Ziel, die Erde zu beobachten. Und der Hintergrund ist natürlich, besser zu verstehen, was auf unserer Erde passiert, warum schmelzen die Gletscher ab, wie stark ist unsere irdische Atmosphäre von Gasen belastet, die der Mensch freisetzt. Ein riesiges Programm. Wir haben also eine ganze Serie von Satelliten in der Pipeline, alle mit dem Ziel, die Erde zu beobachten.
Satellite monitoring of carbon dioxide over a year produces a picture of the Earth breathing. In the northern hemisphere, green plants inhale CO2 in spring and exhale it in autumn, while the opposite is true in the south. Every year, the residual CO2 levels creep up. There is more CO2 in our atmosphere than there has been for 800,000 years, making Earth hotter than when humanity was born. The unprecedented situation requires our scientists to take on the role of navigating Spaceship Earth. Everywhere in the world, they are assessing the impacts of global warming and trying to foretell what future lies ahead for our ship. Their attention is focused on the Arctic, where warming is most extreme and the ecosystem is collapsing. Young researchers are working across the remote region. They are analyzing thawing permafrost, changing animal behavior, the decreasing reflectivity of snow cover, melting glaciers, and unusual plumes of ancient gases. It is an extraordinary opportunity for a new generation of scientists to take on the most important challenge the world has known.
Ceux-ci sont des mares de fond. C'est des petits étangs qui sont formés par le dégel du pergélisol. Et le fond est tapissé avec des micro-organismes qui produisent du méthane, un gaz à effet de serre important. C'est ce gaz que nous voulons échantillonner. C'est la première fois que je fais de la recherche en Arctique. Ah oui, j'adore, c'est vraiment beau. Je rencontre d'autres chercheurs qui font des affaires très intéressantes. C'est toute une expérience.
They are the first in their fields to witness planetary changes in real time. Now, their task is to combine their findings with older data to produce a forecast for the future.
I started doing Arctic research in 1970 when I came to Cambridge as a graduate student at the Scott Polar Research Institute. I started working on waves in ice. But I'd already been on a voyage that took me to the Arctic and the Antarctic as a research assistant, so we saw both ends of the Earth, and that inspired me to take up polar research as what I was going to do with my life. When the Navy decided to send the first British nuclear submarine to the Arctic, the director of the Scott Polar Research Institute persuaded them that it would be a very good thing to do scientific work and collect ice thickness data, so he pushed me forward as the person to do it. So I've been going on them for about 40 years now. We'd be going out in the winter months. The ice then was very formidable. Most of it was called multi-year ice. That's ice that survived more than 1 year. And it was very thick, maybe 3 meters thick, heavily ridged with these great piles of deformed ice. Nobody had managed to get to the North Pole in an icebreaker in those days because the ice was so heavy. In the last 15 years, the amount of multi-year ice has diminished, and now there's scarcely any left. Nearly all the ice that's in the Arctic in winter just grew that year. So it's very thin, so it's only 1 meter or so thick. It doesn't have many ridges. It's easy to break through, so you can routinely go to the North Pole in an icebreaker now, crashing through this stuff. To somebody who's used to the Arctic as it was in the 70s and 80s, it's just a different world. Well, I think the summer ice is going to disappear very fast, and my prediction is it'll happen in about 3 years' time. There'll still be ice filling the Arctic Ocean all through the winter, but it will all disappear during the summer months. The Arctic has warmed up about 3 times as fast as the planet as a whole. There's an amplification factor. So what happens in the Arctic is what's going to happen to the rest of the planet in a few years' time.
Scientists working on the ice caps of Greenland and Antarctica are also seeing unprecedented melting. As ice melts from the glaciers, the ocean is rising.
The second picture gives you sea level rise, which is the result of melting of bodies of ice across the globe, as well as thermal expansion of the oceans. And here, during the last century, we had an average increase in sea level of about 17 centimeters.
Since 1988, the United Nations Agency, the Intergovernmental Panel on Climate Change, has been amassing data from the world's scientists to understand what global warming will do to our ship. For more than 10 years, Rajendra Pachauri coordinated their efforts.
Now we have enough observations on the basis of which we have come up with very clear findings in the reports of the IPCC. And incidentally, these reports are written by the best scientists from all over the world. The IPCC doesn't pay any of the scientists anything for the work that they do. But the sheer importance of being part of IPCC reports is enough to see that they put in those extra hours. This is the only planet we can live on. So we have to be concerned about it. The Earth's climate system is a very finely balanced system. Nature has a certain order in everything that it does. With warmer temperatures, you'll have a higher level of evaporation of water. So therefore, that's going to affect precipitation, that means rainfall and snow. As a result of warming, the bodies of ice will melt much faster. The oceans will expand because of the heat that they are absorbing. And therefore you will get sea level rise, both as a result of the melting of ice as well as the thermal expansion of the oceans.
It is certain that the global ocean will rise through this century and the next, though no one knows how much. Predictions range from 40 centimeters to 6 meters. Even the lowest prediction means that in this century, 100 million coastal people will be flooded annually.
Complex nonlinear systems can behave in an abrupt way, and even worse, they can behave in an irreversible way. You have activated or transgressed a tipping point. If you stand in front of an abyss and somebody gives you a push from behind, you may fall down. If this person, after you are falling already, would just take the hand back, doesn't help you in any way. You will not miraculously re-emerge and be put back onto the cliff. That's what we call a tipping point. The so-called Gulf Stream system in the ocean, where we have seen a slowdown over the last decades, quite a significant slowdown already. So there have been, of course, speculations, could the Gulf Stream be shut down completely? Yes, it happened during the ice ages several times. With Greenland melting, there is a very high chance that not only this circulation will slow down in the North Atlantic, but it may be shut down completely. So that's another tipping element here, clearly. The situation for 3 or 4 years now in the United States, Canada, but you have extremely warm weather on the west coast and extremely cold weather on the east coast. This has to do very likely with the warming of the Arctic, the retreat of the sea ice, which is affecting what we call the jet stream. This is this ribbon of high-speed wind around the northern hemisphere. And in general, this jet stream is creating certain waves for a few days only, so-called Rossby waves. Now, what we find is with this disproportional Arctic warming, these Rossby waves get stuck. They can create unusual heat waves or the Californian drought. This is a big surprise for many people because they feel global warming means, oh, it's gradually getting warmer. But that our dynamical weather patterns are being reorganized through the perturbation of the jet stream, for example, in a highly nonlinear way by human interference, it's a completely different story. It's fascinating, but it's also terrifying.
We are living in a world which already has a lot of stresses. If you look at some parts of the world, there already is a major problem with availability of water. And with climate change, in some places, that's going to become far more serious because climate change only adds to some of these stresses.
The complex interactions of climate change include the unforeseen ways people react to it. In California, the long drought has decimated crops and driven up commodity prices. That change in the market created a disastrous chain reaction far away.
The price of corn is getting higher and higher because of the drought situation in America. Then the production of corn from America is getting less. Then the price of corn is double this year. So the people start to grow more corn. They cut the tree. For corn plantation in the upper north, it creates a lot of problem.
When Thai farmers clear-cut their forests in reaction to the American drought, they created conditions in their highlands that allowed monsoon rain to flood their coast.
A part of that, it is a natural disaster. In the year 2011, the rain increased up to 32%. And we had 5 tropical storms and also another 3 monsoon. Never happened before.
The forest in the north of Thailand could not hold back the stormwater. It flooded the coast even as waves pounded it from the sea. More than 800 people died. Mangrove forests that normally protect the coast against sea surges had also been cut down to make room for shrimp farms.
The nature of the mangrove trees, it contains roots which protrude from the stem of the trees, and it keeps the soil stable, not moving by wave or by tidal currents.
Here, a rising sea met the expanding world food demand with disastrous results.
It used to be a mangrove forest, but now it become firstly a shrimp pond. Right now, because of the decline of the water quality, so the degradation of water quality, so they cannot produce shrimp anymore. Before, we did not know that a mangrove forest is a natural defense system which works perfectly. Now we're going to see the original electric pole that used to be on land, but now it's under the sea. You can see the line of the electric pole. The coast is about 500 meters from this pole. That is a coastal protection. That is done by local people. So they use bamboo instead of concrete because bamboo is much cheaper. But bamboo cannot last for long, so it will break further.
The devastation of coastlines is a human disaster in poor countries and an economic disaster in rich ones.
Again, seeing here a live view of Hurricane Sandy as the International Space Station flies above it, about 260 miles above the Atlantic Ocean.
Water actually built up in the station to about 3.5 feet. And you can actually see the water line that extends going across. And that stayed here until basically the tidal surge pulled back. And then the water level dropped here to about 6 inches. but it dropped here at 6 inches. That meant everything here, all the way down to the track level, and going out about 2,000 feet north of the station was completely submerged. This station was commissioned roughly around 2009. At the time, the structural components and the finishes cost the New York City Transit roughly about $550 million. When this station opened, it was state-of-the-art. But when Sandy did come, all the station components were completely submerged and will need to be replaced. 15 million gallons of water entered our system from the track level all the way up to the ceiling, extending all the way through the station length, which is approximately about 600 feet long. The water level reached every area, went through every single conduit, every single room that was in this complex, and even further north, it extended outside our station limits. This is the dispatcher's room. This was, at one point, state-of-the-art. But as you can see here, this will all have to be completely gutted. We've seen these types of storms come at a more frequent basis, without a doubt. So it's something that we have to look at. We took 66 million gallons of water into our system. If that water didn't come into our system, where would that water have gone? Well, besides us just looking at our mitigation, really the city and the state needs to look at an entire plan for mitigation, because whatever we do will impact others, or what others do will impact us.
Human communities are beginning to plan to withstand the storms of global warming. Other species can only flee.
So out here we are looking at vegetation change on Herschel Island, so how the plants are responding to climate change. So there's a bunch of things going on. One of the things is that the climate is warming in the Arctic. Up here, the summers aren't getting warmer per se, but the growing seasons are getting longer, so the ice melts out sooner and it refreezes in the autumn later. So that means that the plants have a lot more of a chance to grow. You also have a deepening of the active layer, the part of the soil that is unfrozen in the summertime. And when that gets deeper, the different plants can grow their roots deeper and access different nutrient pools, and so potentially grow more. So that's one of the questions with the shrubs, is perhaps they're increasing because that thaw depth is getting deeper and they have more nutrients to grow. Okay, one last one here. That's good. Got it.
Everywhere on the planet is now affected by human activities. There is no natural without human any longer. The whole of nature is now responding to human global scale changes to the world. Well, one of the most obvious changes is that species are moving to higher elevations in mountains because it gets colder at higher elevations, and they're moving towards higher latitudes closer to the North Pole and the South Pole. And that, if you like, is the real kind of signal that it's driven by differences in the amount of warming in different regions rather than by some other factor which is changing in the environment. Species are moving their range throughout the world. The best evidence is from Europe and North America, because that's where there have been most volunteer amateur naturalists who've been recording the distributions of species for many, many years. if this rate of movement carries on for the next 100 or so years, which is the general expectation with climate warming, then the whole distributions of animals on the whole planet are going to move to somewhere else from where they used to be. So this is just a major rearrangement of the whole of biological life on Earth.
IPCC reports document dozens of animals on the move. The famous North Atlantic cod stocks are shifting towards the Arctic. Australia's flying foxes have shifted their range 750 kilometers to the south. North American monarch populations are crashing as strange weather patterns throw their continental migration into chaos.
If there's no more habitat available, then they'll get kind of squeezed as they will be failing to expand in the north, but they will be retreating in the south. And so you effectively fall off the top of the mountain, and either the species will become extinct, or we as humans would have to think about, can we save them in some way?
George DeVolke was one of the first biologists to witness Arctic species collapsing because of warming. For 40 years, he has been studying black guillemots on a remote Alaskan island. The seabirds, like polar bears, depend on the fish habitat that flourishes under ice.
The ice was pulling offshore and taking their food away. And then I started seeing these major die-offs of chicks in the nest.
Then, polar bears arrived.
I slept in a tent with nothing other than my shotgun, and frequently not even unpacked because I never saw a polar bear, for 28 years. And suddenly we had a mother with 2 full-grown cubs coming up to our tent site. Polar bears are obviously the best known and most iconic part of the pack ice ecosystem. If you see a polar bear, you are seeing X number of Arctic cod that have been eaten by a seal, and then the seal's been eaten by the bear. After I got over my fear of polar bears, I started really feeling sorry for them. So they swim in 150 miles or more. They then get to land, they're exhausted, they're looking for anything, and they are eating things like guillemot eggs and guillemot chicks. Male polar bears can weigh from 800 to 1,200 pounds, and to have them be eating something as small as a guillemot egg, which is not as big as a hen's egg, makes you realize that they are very hard up for food.
Like all scientists tracking biological changes, George is witnessing visible changes in biospheres that have been stable for millennia.
I didn't think I would be seeing the loss of a major ecosystem, or seeing a species that basically has depended on that system for the past 25,000 years have to deal with the loss of that system. Knowing that, and then also knowing that people know what the cause of that warming is and nothing much is being done, is very frustrating.
Other creatures are being transformed by the changing environment, particularly those in the acidifying ocean.
The more carbon dioxide that's taken up by the oceans, the lower the global climate change will take place. Originally, we thought this was a good situation. So 500 billion tons of carbon dioxide has been taken up by the oceans. We now understand that over time, that has caused a 30% increase in the acidity of the oceans. And we'll start this model now. The first thing you begin to see is more changes in high latitudes because more CO2 goes into the water at high latitudes. See changes in the Arctic and the Antarctic region first, but now we're out to the present. And as you go out to the end of the century, we see that the entire Arctic Ocean and parts of the North Atlantic and the North Pacific are now corrosive from top to bottom. That means shells and skeletons would dissolve from top to bottom. The same thing is true for the Antarctic region here, all the way out to Australia and parts of South America. But even in the tropical zone, there are conditions no longer favorable for corals to produce their shells or skeletons. This is what the shell normally looks like, completely clear. This is what happens when you put it into 1100 microatmosphere CO2 for 30 days. Look how dissolved the shell is. And some recent work has suggested that we're changing the chemistry of the oceans now, such that we see a whole new chemistry every 40 years or so. A number of organisms now are very sensitive to these changes. The impacts on reproduction, for example, in corals, we see a slowdown in the rate of growth of corals. Corals are particularly important because they provide a habitat, and perhaps 25% or more of the fish that live in the oceans spend some time of their life in a coral reef habitat. So we see that there are implications through the food chain. Some fish in the high CO2 world, for example, the clownfish, they actually move towards their predators in the high CO2 world as opposed to avoiding their predators in a high CO2 world. And they do this because the CO2 has an impact on their neuroreceptors. And so the fear response they have is just the opposite of what it should be. And there are other organisms that do well in a high CO2 world. For example, there's been some studies that suggest that jellyfish do better in a high CO2 world. So you could see there'd be a whole shift in the ecosystem. This is all related to ocean acidification. And what does that mean for humankind? In our planet, about 1 out of every 7 people, on average, rely on seafood for protein in their diet. So we are very dependent on seafood.
およそ地球全体で4000万あるいは5000万ぐらいのですね、生き物がいるんではないかというふうに言われています。研究者の人が今まで調べたそういう生物種だけでもですね、生物種というのはわずか200万しかないんですね。でつまり私たちは全体のわずか 5% しかですねまだ知らないということなんです。一番問題なのはですね、この生き物がものすごい勢いで絶滅しているところなんです。 で実際調べてみるとですね、例えば地球上の哺乳類のうちのですね、すでに4分の1がですね、絶滅が心配されています。で今まで過去地球の歴史の中でですね、どの時点に比べてもですね、最低でも1000倍、場合によってはですね、1万倍ぐらいのスピードでこの変化が起きているというふうに言われているんですね。
5 times before, Spaceship Earth has witnessed major die-offs. Our scientific navigators say global warming has begun the 6th extinction. Its speed now depends on how quickly the planet warms, and that partly depends on feedback loops that we cannot control.
Permafrost is something that is frozen for at least 2 summers in a row. Permafrost can be many things. It can be behind me sediment that is frozen. It can be a lot of ice in the ground, and we call that ground ice, but it could also be rocks. In permafrost, there is actually a lot of organic carbon. Why is it important? Is that because when the permafrost is warming, a lot of that carbon is being released, and it's being released to the ocean when we are next to the coast, or it's being released directly to the atmosphere. And the subsequent release of carbon is what we call the feedback effect, or feedback loop. The way it works is that permafrost gets warmer, the layer that thaws in the summer gets deeper and deeper every year, and the carbon that was stored in the permafrost for tens of thousands of years gets released to the atmosphere. Then that carbon, as greenhouse gas, influences the climate also, and it gets warmer. And if the climate gets warmer, then we get like more thawing of that active layer in the summer. And the more thawing we have, then the more carbon get activated. So this is what we call the feedback loop, because like one process influences the other. And that goes on until probably all the carbon that is there stored in the permafrost is used to be released in the atmosphere.
Permafrost extends under all of the Arctic land masses, but it also extends out to sea. It's a kind of relic of the last ice age. If you have warm water, the water melts the seabed, the permafrost melts, and that releases methane because there's a lot of methane trapped under the subsea permafrost. And methane is a very, very powerful greenhouse gas. It's more than 20 times as powerful as carbon dioxide. So if you release a lot of methane into the atmosphere, you're going to accelerate global warming. And that's what seems to be happening at the moment.
There are probably some below it, and I think that there's definitely some little ones right here in the surface above it. Okay. The bottom of the lake is where organic matter, which is dead plant and animal remains, is being digested by microbes. In Russian, they say that the lake is eating the permafrost, and I really like that analogy because, in fact, it is. When they digest that organic matter, they produce carbon dioxide and methane. Methane does not like to stay in the water, and it comes out of solution and forms bubbles. But there's the methane coming up right there. That's a nice example. Okay. That was way up there.
Well, yes, warming events can be very harmful. Today, the world is just sort of starting to show signs of the conditions we saw at the end of the Permian. The end Permian mass extinction happened about 251 million years ago. It's probably killed around 95% of all species on Earth. And we start to think, well, how could a huge amount of volcanic activity cause a global mass extinction like this? And most of the interest focuses on not the lava itself, but the gases that come out with volcanism. I think the main culprit we think of is the carbon dioxide. It started to release methane. And so what we think happened at the end of the Permian is we get this sort of runaway greenhouse effect whereby we're getting these two gases, methane and carbon dioxide, warming up the planet. Before you know it, the world has just got so hot that it becomes extremely hard for life. And we see a sort of a mass dying of animals on land and in the sea, both at exactly the same time. We're just starting to see the start of that effect. We're just at the earliest stages. Any report from the late Permian would say, yeah, be wary, be careful. The world is starting to break down and losing its ability to cope with greenhouse gases. And the big unknown for us today is how fast things happen. Will this happen in 50 years or will it happen in 5,000 years? And it's really hard to know.
We've never seen a trajectory in the history of our species like the one we're on right now. We're the first life form to become a planet-scale influence and know it. Humans have become the most powerful force driving evolutionary change on the planet right now. It used to be, just environmental change, and now it's us. When you're in the driver's seat on so many different factors that matter to the way the planet works, we're in a race between our awareness and our capacity to innovate and our potency. Are we destined, like most species, when we hit a resource limit to have a jagged rebound period? Or can we, with this gift of foresight that we have, smooth it out consciously? A lot of that's about communication, about education, about awareness, observation. The more of that, the better. Whether it's from a satellite or a young activist working in the forest, the better off we'll be in the long run. We have to get comfortable with the reality that it is kind of a drama, that we now, for the first time, have this ability to observe this stuff. That means if you're a young person right now particularly, you have a special opportunity to engage and find some piece of this puzzle that you can actually affect. By 2050, things are not going to be the same as they were in a big way. This is the first time we've had a juncture in our history as a species that's sort of this powerful, and wow, what a great time to be alive, especially for young people.